So I'm happy to welcome you to our session tonight, to Get into Coding Shape in Math Class with Lisa Floyd. I can guarantee it's going to be a really amazing session where you're going to learn about how to integrate coding into your math classes. It's always great to see people from all over Ontario joining in these OTS Connect sessions, and we're really grateful that you're here with us tonight. So I'm going to turn it now over to Lisa.
Thank you so much. Good evening, everyone. I'm excited to share some ideas for integrating coding into your math class, in particular to enhance your geometry and spatial sense strands. So thank you for joining. And if you're interested in connecting on Twitter, I have my Twitter handle here, Lisa Ann Floyd. Just include the E. I'm just trying to get to my next slide here. Oh, there we go. That's the wrong button. Hope I didn't mess something up there. There we go. Okay. So I normally work at the Thames Valley District School Board in London, Ontario, but I'm on a leave of absence right now. And instead, I've been working at Fair Chance Learning, along with a fantastic team of educators. And with Fair Chance Learning, we offer workshops for teachers and school boards around Canada, actually. And I was actually in the States last week. But we're looking to support teachers with STEAM initiatives, and we're doing a lot of coding and makerspace tools workshops right now to enhance curriculum ideas. I'm also an instructor at Western University's Faculty of Education, where I've been teaching computational thinking and math for all primary junior teacher candidates, and computational thinking and math and science for intermediate and senior teacher candidates. So they take a 9-week coding course as part of their Bachelor of Education program with me. So it's a wonderful experience for me to be part of that. It's one of the first in the world, and there's a couple other universities starting to teach that as well now. If you want to email me, it's lisa@fairchancelearning.com, and I do have some posts at lisaannfloyd.com. Some of them, you'll see some of the ideas in today's session. Now, for those of you who have seen a webinar, or if I've done some PD with you before, some of the stuff at the beginning will be a bit of a repeat, but then I've made some new materials for tonight and hopefully give you some new ideas. So we're going to be using coding as a context to develop computational thinking skills. And what I've done here is I've listed some of the main aspects that I believe computational thinking encompasses. So when you're supporting your students with computational thinking skills, you're helping them to be better problem solvers. And some of those terms include decomposition, so helping students to break large problems into smaller, more manageable pieces when we're doing coding. That certainly helps with that. Also, students are creating algorithms rather than just following algorithms. So typically in math class, or often, not always, sometimes students are expected to follow a step-by-step algorithm to solve a problem. Whereas in the real world, there really isn't well-defined problems. So it's kind of good if we can offer them ill-defined problems, and then they can actually write code to solve the problem. So they're creating their own algorithms. Also, the term iterating is a term in computer science, but as you'll see today, it's also something that kind of can apply to real-life examples, in that students will create stuff and then create another iteration of it and another to make it better each time. I'll explain some more of these terms as we move along through the session this evening. So why do we want to teach computational thinking or incorporate it into our lessons? Well, studies have shown that it's a powerful skill that can have a positive impact on all areas of children's learning. It also has been proven to foster problem solving for our students and encourages them to value the fact that there are more than one solution, or there is more than one strategy for solving problems. And for any of you who have been taking professional development or have attended professional development sessions in math lately, we know that that's important to have students value, that there's more than one way to get to the answer. Some just might be more efficient than others. This is one of my favorite quotes that I read in an article by O'Brien. Math should make sense to children. We should encourage them to be thinkers rather than storage bins for thinking done by others. And I think no matter what subject area we teach, that's something that we see, as teachers see, as being very valuable. Helping them to think. So what about coding in math class? Why do we want to do that? Well, I'm going to be sharing some of the work of Dr. George Gadanitis this evening, and he did some research that goes around the idea that coding should help enhance understanding of math ideas. And it makes sense to use coding as a meaningful context for learning math because both math and coding share a common logical structure. And since tomorrow's Valentine's Day, I thought I would include a little heart diagram on there. So math and coding go very well together, but it can certainly be used to enhance understanding of other subject areas as well. The focus today is just going to be, or this evening is going to be on math. So we're going to have a little poll now. So you're going to see, in a second you're going to see A, B, C, or D up on your screen on the left-hand side, and you're going to be rating your current coding experience or knowledge so far. So there should be a pull down just beneath the participants area there. You can see that you had to click on A, B, C, or D. So you should see the letter A right now. If you click on the pull down menu, you can select what your experience is with coding so far. So I see a few people have answered now. And it's fine to answer in the chat window as I see some of you are. I don't know if Molly wants to explain a little bit better how to access the poll.
The poll is exactly where the check mark was. Over just in the participants window. So if you are able to do that, we're going to publish the poll in just a second.
Okay, so it's no surprise to me that a lot of you have limited or some understanding, and generally we do have a few with considerable and thorough usually when we do this kind of poll, so that's great. We'd love to hear some of your ideas for those of you who've used it in the past or who are using it right now. So it's great. I see someone has used Logo and been doing Scratch more recently. Great. So this evening we're going to be doing a lot of Scratch examples just because it is a free web-based software that we can use. All right, so we're going to move on to the next poll. Great to know where some of you are coming from. I'm also wanting to know now, have you coded with students in math class? So for those of you who have some understanding of coding or some experience with coding, if you can just indicate to me if you have done any coding, if it was for math class, yes, no, or if you haven't been doing much coding, not applicable. Okay, so a few of you have, and most people haven't done coding in math class, so hopefully after this evening you'll be inspired, and I'll share some resources with you as well. Okay. So as you know, geometry and spatial sense is across the grades in the Ontario curriculum, from grades 1 all the way up to grade 8 and continues on through high school. And it's important, even if you teach just grade 4, that you know where your students have been coming from and where they're going in the future with it. It helps students to understand connections, you know, what they learned in the past, why it's important for what they need to know now, and then it helps them to understand where they're going next as well. So research shows that there's a very strong link between spatial reasoning and success in math and science. So students who are preschoolers, they actually, if they have strong spatial reasoning skills in preschool, they tend to be the first ones to read. They also tend to do better in math and science later on in school, and this extends up to high school and even university. Now the good thing about this is that spatial sense is something that's considered malleable, so we can actually help enhance students' spatial skills or help to develop them at any age. And while it's most important to develop this when in the primary grades, it also makes a difference to be helping students to develop them in the later grades. And we believe coding will help. Coding in geometry will actually help increase or develop spatial reasoning skills in students. So I just noticed I forgot that my animation wouldn't show up, so you can see where I was going with this. But often what I'll do when I go into a classroom is I'll have students try and program me to do something, sort of like a robot. And one of the first things I might do is hide under the desk and then ask them to give me instructions, specific instructions, to get out from under the desk and out the door. So usually the first thing students will say is stand up, and so I'll bang my hand on the table and pretend I've hit my head, because they've not given me specific instructions to like crawl out and then stand up. So it's just kind of a silly way to get them to realize they need to give me step-by-step instructions that make sense. Now it's called pseudocode. So programmers use pseudocode when they are planning out a program, so they don't have to worry about the syntax, and syntax is all the little like colons and periods and brackets that you typically see in some of the images of coding that you might have seen online. But they just write it in more English language so that it's more readable. So in this case, I would ask the students to tell me how to walk in a square. And usually the first thing they'll say is move forward, and they don't give me a quantity. So then I'll just start walking forward and I'll run into the wall. And then they realize, well, they have to tell me how many steps to move forward. So then they'll say move forward 3 steps. Then they'll tell me to turn right, and I'll just start spinning to the right. And then they'll realize, well, they have to tell me how much. Now, in some instances, depending on the grade level, they might tell you to do a quarter turn, or some of the students might tell you, to turn and face the wall with the green painting or something like that. And then in some cases, they will know that 90 degrees is a quarter turn. So they'll say turn right 90 degrees. Then they'll realize, oh, you need to do that again. Move forward 3 steps, turn right 90 degrees. Move forward 3 steps, turn right 90 degrees. And that will get us a complete square. But in computer programming, we're very efficient. We don't tend to do the same thing twice, or we never do. We will use what's called a loop or a repeat. So in this case, we have move forward 3 steps, turn right 90 degrees. I keep thinking you can see my cursor. I realize I need to use the pen here. Oh, there we go. Okay, so you're going to use the repeat and move forward 3 steps, turn 90 degrees. And you do that 4 times because it is a square. So what I'm going to have you do now, and this is optional, you can go to this link, which is bit.ly/drawsquare, or you can follow along on my screen. So it's up to you. I'm not going to be sharing my screen with you. I'm actually going to be sharing screen prints of the program that you will go to if you go to that link. So if you go to bit.ly/drawsquare, now you can do this on, it has to be on a computer. For those of you who are working on an iPad or a tablet, Scratch will not work, so you'll just have to follow along by watching. And I will at the end give you a link to all of these resources, and then that way you can share them with your students if you'd like to have them do the same thing. So once you go to that link, you're going to come to a Scratch program that looks something like this. So you can try splitting your screen if you want to. Or you can just follow me along, or just listen to me as I speak and follow along. So you can see we're trying to draw a square now. And if I run the program, if you click the green flag at the very top, it says watch. It's supposed to say watch, but on yours it will say the right one because I fixed it. It'll say watch me draw a square. And then it will draw what the code says to do, which in this case is going to be a bit of an L. So here we have move. I'm just going to get my pen again for you. Okay. So we're going to move 100 steps, wait a half a second, move 90 degrees, wait a half a second. Then it moves 100 steps, which is not very big in Sparrow. That's why it's not that many, or not that long. And then you turn 90 degrees. So that's all we've done so far. So what you're to do, and what some of you might have tried to do if you're already on the link, is to use the blocks down here, move them up until you end up with a square, and then you'll click the green flag, which is around here somewhere on your screen, to run the program to see if you're correct. So you're going to move each of these up in the right order. to try and make a square. You can see that in Scratch you can add comments. Now, in programming languages, programmers include comments that explain their code, because then they have to share code with other people. But I tend to use them in Scratch programs to give students instructions. So I will give them a link, just as I've given you the link here, and you can, and then they'll know what to do. Okay. So once you have all the blocks in the correct order, you will see that you will end up with a square. But as we talked about a little bit earlier, as I mentioned, computer programmers are efficient. So instead of using that many blocks, you can do that for effect so that they realize it's much more efficient to actually use the repeat block here. So here we have a repeat of 4 because there's 4 sides. And then you bring in the section of the code that is repeated 4 times. So rather than repeating that whole section 4 times, you just grab the one section, throw it inside of the repeat, and then attach it. So here we have our square now when you run your program. So it's just more efficient using the repeat block. So with that same code, if you want to stay on that link, you can continue to follow me along here. We're going to change it to a triangle now. So right here we have a square, and there was 4 sides. So the first thing we should do actually is to change what the bug says. So right now it says, watch me draw a square, and you want to change the word in the say block to watch me draw a triangle. The second thing you want to do is change the repeat. So because there's only 3 sides in a triangle, we're going to change the repeat to 3 instead of 4. And then we also need to change the angle. So right now it's at 90 degrees. So think about what it might be. Most people, as many of you might have tried right now, 60 degrees first. And you'll end up with something that looks a little bit like part of a hexagon. And people do 60 degrees because they recognize that the interior angles of a triangle is 60 degrees. But that's not quite what's happening here. We have to actually use 120 degrees. And the best way to figure this out is to actually get up and to walk the square, or walk the triangle rather. So when you walk the triangle, you'll realize that when you start to turn, and this is what happens with students as well, they realize that they're actually turning more than 100 degrees. And they can keep trying through discovery to see how many degrees they need, or they might figure out that it's 120. So you know that the interior angles are 60, and if we extend this line, we've got this angle here that we're looking at, and the 60 degrees, you've got 2 supplementary angles in this case, so it's 180 minus the 60 to get 120. So the triangle is actually a little bit tricky for students. And again, then you're getting into supplementary angle rule. And whether you explain the supplementary angle or not, that's up to you. You can decide if that's important, or maybe your students will just do it through discovery. So to make it run, Deanna, you just click on the green flag, which on your screen should be about over here. So just click on the green flag. Thank you, Scott. So you'll notice that students are getting immediate feedback, and the coding program is actually acting like the teacher. So they're going to try over and over again until they get it right. And rather than sitting there waiting with their hand up, they can just keep trying it until they finally get the shape that they're looking for. So now I'm going to have you code a circle. So for the circle, you're going to be watching a video link. And if you've already closed the Scratch program, you're just going to go to Scratch. You can just Google Scratch and you'll get to scratch.mit.edu. So we're staying in the Scratch program. For those of you who are already in it, you can either delete your code or you can go to File, New, and start a new program. But we're going to be going to this link here and watch the video. So you're going to be doing this on your own because as you're doing it, you're going to try to code the circle, for those of you who have a computer to do so. And you might pause the video, replay certain sections. And it's a 2-minute video of me explaining how to code a circle, but also how to make a new Scratch block. So we're getting into modularity for those of you who are familiar with coding. Then, if you have time, you can go ahead and code the bit.ly/circle circle. So you're going to go to this video link and watch the tutorial of me explaining how to make a circle of circles that looks more like this. So it's kind of a cool diagram. So I'm going to set my timer here, and I'll give you about 6.5 minutes to watch those videos and see if you can code them. And certainly ask me questions. I'm going to stay on this window here so I can see if you have any questions in the chat window.
And I put 6 minutes and 30 seconds on the timer, so there'll be a ding when it's over.
Oh, perfect. Thank you. Okay, I'm not sure if that frightened any of you, but it made me jump, even though I was anticipating the time to be done. So hopefully that gave you enough time to try out the circle and the circle of circles. The students quite enjoy making the cool diagrams of circles and other shapes. And once they get good at it, there's unlimited possibilities with that. So if you have any questions, just let me know in the chat window. But I'm going to keep going if I don't see any questions. What I'd like to do is another poll here. I want to know if you were successful in coding at least a circle. You can see the poll is already ready. Thank you. Eventually. That's awesome. It does take a little bit of try, especially if it's your first time using Scratch. But students as well, it will take a lot of tries. No problem. So most of you were able to get that circle coded, it looks like. Okay, Brenda, so actually if I can just get, I'll type in the Scratch address in a second, or if someone can do that for me, that would be great. So scratch.mit.edu, but you can do that again later, Brenda. Thank you, Scott, except for no double R. I was hoping you'd type that in for me. Okay, so for the next one, instead of doing a poll here, what we're going to do is use that emoticon that some of you were here for the intro session at the beginning, but you're going to be drawing a little diagram, and I was hoping that Molly can maybe jump in here and explain better than I could where to find the little diagram so that you can indicate with the screen stamp which grade level you think is the lowest that you would go for coding those sort of shapes. So would you try this in grade 1? Let me know the lowest grade you would try to do this.
So again, we can use the common symbols chat, or the common symbols in the clip art. So that's at the very bottom of the whiteboard tool. So if you want to select one of those and just drag it over to whichever grade, beside which grade you would like to, you think you could do this at the lowest. Or if you're not able to access it, you could just put it in the chat box too.
Awesome, thank you. Okay, great to see, Andy, that you've done this with grades 3-4 class. And Jamie's done some stuff with Scratch Junior. That's awesome. There is a session coming up. I've got to double check the dates, but I do have a primary section for including Scratch Junior on the OTS webinar. Okay. So the majority say grade 3. I'm actually surprised. I thought people would say older grades, but I agree. I think you can adapt to do this with primary grades for sure. And yes, Andy, you can code Scratch in French on the main screen. When you go to Scratch on the bottom, you can change the language, and there's a number of different languages available, but French is definitely one of the options. Okay. So I'd like to show a video, and we're going to show this for you. I believe some of you on certain devices will not be able to access the link or watch the video possibly, but the rest of you who are on computers should be able to view this link right now. So we're going to be watching the bit.ly/scratch123 video.
And if you are on a mobile device, I'm just going to put the link in the chat box, and you can just click on that. So I'll do that first. You can click on that and watch it, and then I'll just put it in the web tour as well. And we're watching it together, but if you can indicate when you're using the check mark tool when you're finished.
So I'm just going to give you a bit of context for this video. So what happened here is this is a school in Toronto District School Board, and this is a project by Dr. George Gaddanitis, who I told you about, and I'll share some of your resources, his resources with you again in a second. So the grade 7-8 teachers were, or grade 7-8 teachers taught their grade 7-8 students how to code shapes in Scratch, and the grade 7 and 8 students went into the grades 1 and 3 class, and they coded with the grades 1 and 3 students. And these are the grades 1 and 3 teachers here talking about that experience. All right, so you can hear the excitement in the teachers' voices. It was quite an amazing experience for them. Especially to have all those grade 7-8 classes come in, it's a wonderful leadership opportunity for your more intermediate students. And then at the same time, it also helps out the teacher, because especially in grades 1 and 3 class, you're going to have students with a lot of questions, and then you have a whole bunch more teachers in the room. So when you're doing this, I saw someone mention earlier that it's neat to do this sort of thing in Scratch, because students will get up and try and figure out how many degrees they need to rotate, and they're learning through discovery. And so what you can do is they'll say, can I try and make a circle? And you'll say, well, why don't you try coding it? And one of the first things they'll do is they'll stand up, and then they'll realize that they have to move a little, turn a little, move a little, turn a little, and so on. And then they'll sit down, and the first thing they'll try and do is maybe type in like 100 for repeats, and then they get, a quarter of a circle or almost a quarter of a circle, and then they'll do it they'll try again to see if they can get closer to a full circle, and they might type in 200 and then 300, and eventually they end up with 360 degrees. And so they've discovered that it's 360 degrees in a circle if they didn't already know that. So they'll remember that for a while. And yes, I see Jan calls it body geometry. And Seymour Papert, one of the fathers of computational thinking, or grandfathers of computational thinking, I guess, does refer to it as body geometry or synchronicity. So having students be knowledgeable about their bodies in order to understand spatial sense. Another affordance of coding is that it resonates with traditional manipulatives. So many of us use manipulatives in our classes already, and sort of like the counters or the fraction bars and these sort of blocks. Well, coding is similar to those manipulatives. It's helping your students to understand math ideas. So we're going to take a look at debugging. So often what I'll do with my students is I'll share a program with them, and that has an error in it, and they have to try and figure out what the error is. So there's a slide here, or a link here, and I'm going to just be going along on my slides. I have screen prints, but you can go to the bit.ly/debug square. Oh, sorry to hear about the no sound. Although I guess you can't hear me say sorry. All right, so let's have a look here. When you get to this link, so this is a Scratch program, and again, I often give my students Scratch program links so they can remix the code, or they can make corrections as they will in this case. So when they draw it, they'll realize that, or when you press the green flag, you'll realize it's not quite a square, and the students would have to figure out what's wrong with the code. In this case, I'm just going to get my marker here working again. So in this case, it's moving 80 degrees instead of 90 degrees. So if they've already done a square, that should be a quick fix for them, and they'll change that 80 to 90 and end up with a perfect square. So there's a debug square program for you to share with your students if you want. Here's another one. It's a hexagon. So again, you're welcome to go to this link to try this program yourself, or what you can do is just follow along on the slides here. So we've got, watch me draw a hexagon, and you'll notice there's two errors. It says, oh no, Beetle has made two errors. Debug the program so that Beetle draws what he intended. So here we've got a repeat of 3, and so it's only drawing the 3 sides of the hexagon, and there's another problem as well. But let's fix the first problem. So we're going to change the 3 to a 6. Okay, now we've got something that looks more like I think it's called a nanogram, so something like 9 sides. So what we want to do is change that 40 degrees to the correct number to make a full hexagon. So students will, so right now it's 40 times 6, which is 240, so it's not quite a full circle. We want it to be the full 360 degrees, so we change it to 60 times 6, and we've got the full 360 degrees, and it makes the circle. So again, what we did there is we looked at the exterior angle. So we extend this line here, and then realize that it's this angle that we're actually trying to code. And if you walk it, it helps you to realize that it's 60 degrees that you're turning each time. So 60 degrees there, 60 degrees again. Let's try another one. Now for this one, I'm not going to show you the link. I'm just going to show it on my slides. You can see, oh no, Beetle has made an error. He wanted to draw a full circle of circles, which you guys did on the slide earlier. Can you debug the program so that Beetle draws what was intended? There's more than one solution. So when we play it, we're going to see that we're only getting a half circle of circles. So there's a couple different problems here. The first thing we could fix is the number of repeats. So instead of 6, if you want to type in the Scratch or the chat window, what you think the repeats could be changed to, if that's what we're going to change first. If anybody is aware of what we should change that 6 to make it a full circle of circles, you can just type it in the chat window here. Yeah, so it is 12, and if you did 24, it would just draw on top of your previous circle, so it would look like it would still work. But the exact number would be 12. So we're just going to double that, and now we have double the amount of circles and a full circle of circles. Now there's another way that we could have changed that. Because we didn't specify the number of circles, what we could do, instead of changing the repeat, we can change the number of degrees. So right now it's like 30 degrees times 6, which is 180. So you have a half circle. So Deanna, we don't have the link for this one. I could share it with you afterward on the resource that I'll share with you so that you can share it with your students. But for this, we're just following along on the slide. So you could change it to 60 degrees. So 60 times 60 is 360. We have less circles, but instead, or we have less circles, but it's still a full circle of circles. So there's just two different ways that you can change that program, and your students could change it and show you that they can change it in other ways too. Perhaps they will reduce the number of repeats and change the number of degrees and change both of those variables. So when you're doing this sort of thing with your students, they're going to make errors all the time. But what you see with coding is that your students, and the teachers as well, begin to accept that failure ultimately leads to success. So to fail is not a four-letter F word, it's the first attempt in learning. Students will start to develop that growth mindset and will realize that they can actually be successful. They just have to keep going and put their mind to it. If you're interested in coding or math, I'd recommend that you read this book, Mindstorms, or maybe a couple chapters of it. It was written in the 1980s, but Seymour Papert was such a forward thinker and had such brilliant ideas. And you'll read it and you'll be like, how is this possible that it was from 30 years ago? Every page has a quote that I like to write down. But one of my favorite quotes is, typically in math class, a child's reaction to a wrong answer is to try to forget it as fast as possible. In coding, however, the programmer is encouraged to study the bug rather than forget the error. It will pay off. So I think that's naturally we all see that as being valuable. We see when students make mistakes, it's just such a valuable learning opportunity to talk about it with them. And so often, this is not an exaggeration, this is what you will actually see with your students. They get really excited when they are stuck on something and then they stick to it and problem solve. And sometimes you'll see students staying at lunchtime. You'll be trying to get onto your lunch duty, and they're all in your classroom still trying to debug each other's programs. They can't stand when someone has a problem in their program. So we'll start to get together and debug it in a collaborative way. So I'm just reading what Joe mentioned here. That logo is awesome. Calling the triangle a turtle was a stretch, even the graphics of those days. Okay. So check out that book if you want to learn more about logo and the history of it. So I'm going to show you some examples now of unplugged. So guess that shape. So here's what you can do. You could have slides up, and I do have screen prints of these for you on the resource that I will share with you. So you can see I have some code here, and I would display, there's a couple different ways you can do this, and I'll share with some examples for you in a moment. But if you displayed this on the screen as sort of a minds-on at the beginning of your lesson, the students could figure out what is happening in this code. So let's focus on this part here. So does anybody want to try to figure out what shape that is? Take a moment. Okay, a couple of people have figured out. So it is a pentagon. Awesome. And I guess the 5 sides gives it away. But also, you can take a look at the 72 degrees is significant as well. So let's try another one. So yep, there's the pentagon that you will see. Here's another one. So just indicate in the poll when it's ready whether you believe it's A, B, C, or D. So do you think it's an L shape from this code, a square, a rectangle, or a parallelogram? So you can give these to your students and give them multiple choice questions to help them out if you want for a bit of scaffolding, or you could just have them draw the shapes, as I'm going to show you in a second. Oh, thank you. I see you're writing it on there. Great. Okay. So it is a parallelogram. And so you can see, I'll show you what it looks like. So it moves 40 steps, which is not very big in Scratch World at all. And then it turns 40 degrees, so an acute angle. Then it moved 120 steps, a little bit longer. Then it turned an obtuse angle, and it repeated that twice. So there's our parallelogram. And one more guess that shape for you. I'll just let you think about this for a second. Oh, there's a question. So clarify the first blue line, right? So there is going to be a webinar on this, but you can look at Cartesian plane. So in Scratch, when you look at the stage in Scratch or the background, you'll see that in the center is 0, 0. And you can actually get a graph for the background on your Scratch, and 0, 0 is right at the center. So I always code that at the beginning because sometimes students will code their shape way off the screen and they won't see it, and they'll say to me, oh, I've lost my sprite, and so that the only way to get it back is to program it back. So we actually have to say go to 0, 0, so we always start at the beginning. That just ensures you're starting your shape at the beginning. Okay, so it is a circle of squares rather. Now I guess it kind of gives it away because I used a block, just like we did in the video. So we've got the square, turn 10 degrees, change pen color, then it draws a square. So it's referring to this code here. Draws a square, turns 10 degrees, changes the pen color, draws another square, and so on. Yeah, so the point and direction I'm going to be explaining in a second with a protractor. Yeah, coordinate plane is amazing to do with Scratch, especially because in order to do animations in any programming language, you have to know your XY coordinate system. So it's a great motivator for students. So what you're seeing here is when students are deconstructing code with these unplugged activities, in order for them to understand any math ideas, they must first be able to make sense of the world through visualization. And that is exactly what they're doing with their students when they are forcing them to think about the shapes and picture what's happening. And as I mentioned earlier, Patrick describes this type of geometry as being syntonic. So again, we're talking about the children's sense of knowledge about their own bodies. So anytime you can bring that in, they're going to have a better understanding of what they're doing in their math class. So a colleague of mine, Enzo, who is in the Hamilton Wentworth board, what he does is, for an unplugged idea, is he has his students code in Scratch or in Hopscotch. So Hopscotch is also a free programming language that you can use on an iPad. It's similar. So in this case, it was Hopscotch. So what he did is have the students, or what you could do is have your students code in Scratch in groups, and then they can go and write out that code on a piece of chart paper and put it up around the classroom. As the teacher, you know that their shapes are accurate because they've tested them out in Scratch. Then the rest of the students can do like a gallery walk and walk around and try and identify the shapes that they see. So they could write it on a piece of paper, or they can engage in discussion at each of the groups with the authors who wrote the actual code. So that's a great way to incorporate this and make it a little bit more collaborative. Another idea that I've seen is by Scott McKenzie, who is a grade 3 teacher, and he is on here, or was on here anyway. So he's a grade 3 primary teacher, and he'll be doing a webinar on February 28th for coding the mathematics curriculum in primary. So I just wanted to mention that for those of you who are interested in doing the younger grades. But he made flashcards like this of all of the code, and then students took protractors and grid paper and tried to draw them out. So every 10 steps, I guess, in Scratch World would be one little square on the grid paper. So you can see that that takes a lot of thinking, and this is grade 3 students doing this, so that's pretty neat. Great unplugged activities for your students and not too difficult to make for them. As a teacher, you actually make them in Scratch, and you're confident they're right because you can run your program and check that. So let's have a look at what that might look like with your students. Now, it's optional to include this block, point in direction. So depending on the grade level, you might not include that block in the code, and you might not include this block either when they're going through the flashcards as I just showed you. But what you might do with more senior grades, or maybe getting into junior intermediate, is make them consider which direction it's going to start. So they could look at the code and decide that it's going to face any direction, but what you could do here is add this block point in the direction. So let's have a look. You can point to the right, which is 90 degrees, left, up, or down. So for example, we can point to the right, 90 degrees. Okay, or we could point to the left. So we've got -90 for left, Then we've got up, 0 degrees. And then we've got down, 108 degrees. So that's the first thing that they will do, is they'll draw that line first if you've included that block. So again, you have to decide if that's important. Does that add a little bit of a level of complexity for it? So let's have a look at what they might do if they're going to draw this. So this 0, 0 is just something, as I mentioned, I put on to start in the middle. We're going to start off by pointing in the 90 degrees direction. So they're starting to the right. Now moving down to here, they're going to move 75, so you'd move 7.5 squares, I suppose. So we'll draw that line. You can see I've drawn it for you. Then we're going to rotate 72 degrees. Now look at this arrow. It's turning to the left, okay? And so you can see here, it's rotating to the left 72 degrees. So the students put their protractor down and then draw the next line. You probably will have them use a ruler, unlike what I did here. I'm not super picky about those things. Okay, so then we've got the next line. So we move the 75 steps again. Then we're turning 72 degrees to the left direction. Draw the next line. Again, 72 degrees. Draw the next line. 72 degrees. So that is how your students would go about drawing it until they got the pentagon. Now let's say we did the same shape, but we're rotating to the right now. So we're still starting in the right direction, but instead of moving to the left, we're rotating to the right, as this arrow indicates. So there are different blocks that you can use in Scratch. So moving to the right in that direction. So the next line is going to be down, and you can see we're going to end up with an upside down pentagon. So it's depending on, what grade level you're going to teach. Perhaps some students would be happy if they can make the pentagon with the 72-degree angles, and some students you might make it a requirement to have it facing the right direction as well. Okay, so what you can do once you get more into coding with your students is, once they get a little bit more comfortable, you can have them start to draw some art pictures so they can draw shapes in Scratch. And in this case, we call this turtle geometry. And so what I've done is I drew a square, a triangle, a circle for the sun, and then I did a little circle of triangles. Did I do there? I can't remember. It's hard to see for the flower. So you can see it's kind of a neat way. And what we did here is we put the pen up in between each shape. So we draw the shape, put the pen up, then go to the XY corner on the screen. So again, this is a little bit more advanced, but once your students are a little bit more comfortable with it, they'll be okay with it. So here's the 0, 0. So you can have them move the shapes around the screen, draw them, or move the cursor around the screen, draw them, and then lift the pen up again. So it's kind of a neat way to encourage math and art as well. Okay, so you can do, as I mentioned earlier, Scratch can be extended to any grade level. So here we have some stuff that I would probably do in a high school class, but certainly some of your elementary school students would be able to do this. It's tricky, but what's cool about it is sometimes students will write code and they'll be pretty happy with it, but if you want to challenge them more, you'll say to them, well, can you make it more efficient? So here's where it's not just a picture that's pretty and cool, it's actually the code that's neat. So I like this quote, perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. You're trying to make your code as efficient as possible. So we can watch these clips together, but for those of you who are on a mobile device, you're going to be watching it on your own. So these are really short clips, about like less than a minute each. And I just wanted you to see some of the potential that you can do with Scratch. You can go from basic shapes to really complex shapes, and you can really challenge your students. I was just hoping that Molly can go ahead and share this first video with everyone, while the rest of you, and she's got the links there for you to watch it if you're on a mobile device. Okay. So you can see we're making a fractal here. And this was actually made by one of my intermediate senior pre-service teachers on the first day when I taught them shape. So he had some prior coding experience. So this would be, you can either share this program with them, see if they can recreate it, this video, or you can have them try and code something like this. It's pretty challenging, but it's really cool. So what I'm doing here is the number of polygons you can change to, or the number of sides is 3 now, so now we're doing a triangle instead. And while we're watching this, so just getting a bit of feedback, so if some people want to make sure that their mics are off, there's a talk button. Make sure your talk button is off, I guess. Okay, so there's that one. Actually, the next one is what we were going to be doing anyway, so I'll just watch this one. So this next one is something that you can do if you're teaching high school in grade 9, or again, you might challenge your students to do it in a younger grade. But you can have them go outside and take a picture of an image in nature. So in this case, we have the shell. And so in order to do this, we had to use Pythagorean theorem. We also used inverse tan function. So there are some advanced operators in Scratch that you can use. There we go. Okay. So we'll go back to our slides now. So I'm in a TLLP, Teacher Leadership and Learning Program. I think that is what it stands for. So what you can do as Ontario educators, each year you can apply to the Ministry of Education. Just Google TLLP, Ministry of Education, and you can look for the link for that, so you can figure out how you can apply for those. We actually were granted thousands of dollars in our school board, and it's a teacher-led project, and we're doing a project to check how coding can enhance understanding of math ideas and also improve attitudes towards mathematics by incorporating coding. So this example was developed by one of my colleagues, so we have a hashtag MathEdCoders if you want to follow it along. So he had open-ended challenges. So you can give your students, and he has provided the link, so it's at the bottom there, and you can see it on your chat window as well. So he says something like, I have 4 sides, 2 right angles, 1 angle is obtuse, and so on. And then the students can figure out what it is and try and code that shape. And what's neat about it is everyone will code something slightly different, and then it promotes conversation. So here's another example of something you might try with your students. You might have heard of which one doesn't belong. They have an entire website for math teachers called WODVCA. And you can see that you give your students shapes, for example, and then they have to figure out which one doesn't belong. Now, and sometimes I'm not sure if the talking is being, I hear Brenda here's talking on top of my presentation. Hopefully it's resolved. I can't hear any talking right now myself. Okay, so I'll keep talking if we hopefully we'll get that resolved. Okay, so there's shapes here, and students will have to figure out which one doesn't belong. And sometimes there's no one else, or there's more than one shape that doesn't belong, and so it promotes discussion. So here's an example of how you can do it in coding. So we've got some code here. So we're moving 75, turning 120 degrees, moving 75, turning 120 degrees. So we've got an equilateral triangle in the first example. Then over here, we've got an isosceles triangle. So 2 angles are the same and 1 angle is different. Over here, we've got a hexagon with all of the degrees the same. And over here, we've got a triangle, an equilateral triangle. Now, for your students to figure out which one doesn't belong, some might say that the hexagon doesn't belong because the other 3 are triangles, or some might say that this triangle here doesn't belong because not all the angles are the same. So it's great to have that conversation with students, and my colleague who's also in our TLP, Sabrina, suggested doing which one doesn't belong in coding. So we're developing a number of those resources now. And I just wanted to mention that you might also select or choose to use Sparrow. So Sparrow is a robotic ball that some of you might have seen or use in your classroom right now. And Seymour Papert would, I believe, refer to these as objects to think with. And research has shown, so I'm a research assistant for a couple of professors at Laurier and at Western, and I have the privilege to go and do some of the classes, and we've also observed that by coding digital tangibles such as the Sparrow or robotics, we end up with a deeper level of engagement, even more engagement than what you'll see with solely coding. So it's kind of neat for some of those kinesthetic learners in your class. So here's an example of the code that you would see with Sparrow. So we've got, here's the Tickle app that you might code your Sparrow with. The newest Sparrow, Spark Plus, I believe, the Tickle app's not quite compatible with it yet. So in that case, you can use Lightning Lab. So here's some sample code from there. So what happens in this code is the robot will move for half a second, wait a second, then turn right, and it will do that 4 times. So then you code this ball to move in a square. And this is an example of a screen print from the code from the Lightning Lab app. So you can see if you tell it to go in the 270 degrees, that would go left. We're going to watch this video now together. This video is my student pre-service teachers at Western University. I challenge them to do is to make some sort of shape, and in the video they explain the shape that they're going to make, and then they explain how they're thinking throughout making that shape as well. Hopefully we can watch that video now. Awesome, thank you. So you can see they were using body geometry to figure out how they were going to make that shape. This here is, I'll just get my pen again. So this was a maze set up by teachers, and so the students can program their way through that maze, and they have to make use of the properties of geometry and angles to make their way through the maze successfully. What I see when I do things like Sparrow and Scratch is this opportunity for just-in-time teaching. So you'll kind of walk around and listen to students' conversations, and you'll see them struggle a little bit sometimes. And sometimes they'll say, if only I knew how to do such and such. And then I just kind of jump in as the fairy godmother and say, wow, interesting, you should ask that. And then it gives me the opportunity to share something different with them. So it's more authentic because they've sought out the answer. They're curious and they want to know how to do something, and that's where I can jump in and help them out. So I like the idea of just-in-time teaching. This is something that someone did with Sparrow. So Cheryl, who's also in our TLP, she had been doing Sparrow for a couple of days with her students, and then she decided to do an unplugged activity the next day. So she gave them a question. If the Sparrow traveled 1 meter using the code shown, write the code for a rectangle with a perimeter of 36 meters. So she just gave them this little bit of code, a screen print of the code. They weren't actually using the Sparrow for this activity. And this was the math learning that went on here. So you can see the students really thought their way through to figure out how they could code a rectangle with a perimeter of 36 meters. So it's another idea of something unplugged to get your students thinking. So I did mention to you about Dr. Gadanitis. So he has a wonderful resource. It's called Coding for Young Mathematicians. If you go to mathsurprise.com/store, you can purchase the book for about $30. And I don't get commission, but you can use Lisa Floyd to get a 10% off coupon if you're interested. So he has a newer book called Surprises for Young Mathematicians. He also has a number of free resources on researchideas.ca website. So he is a researcher focusing right now on computational thinking in math specifically. So some of the ideas, there's a little bit of shapes in this book here. And you'll see some other ideas, this Cartesian plane, patterning, and all kinds. So I'm about to wrap up here. Before I do so, I want to mention a couple of things since we have a little bit of time here. So I do work at Fair Chance Learning, and we do workshops. So if you're interested in any of these sort of tools, Microbit, some of you might have checked that out in England. If you Google Microbit, you'll know what I'm talking about. It's a really neat coding tool for students. There's Makey, Raspberry Pi, and we do offer a Makey session for school boards. If you're interested, just let me know and we can set something up. I also wanted to mention a website. I'll just put it onto the last thing. It's called mathandcode.com. Since I have a bit of time, I'm going to mention it to you. So mathandcode.com. And on that website, there's a number of articles that are written by teachers who have been, and professors and student teachers as well, who have tried coding out with their math class. And some of them are ideas that you might want to try, and some of them are reflections on how it went. And also, sometimes they're looking for writers for that. So if you're interested in writing, you can send me a message, or if you can find the email. Dr. Gadanitis runs that project, and I had the privilege to be the guest editor for the first few issues. So just let me know if you're interested in writing for that, or just check out the links. There's a lot of awesome resources on there, including some articles by some of the people that I mentioned in my slides, and also one lady who's really close to retirement, Donna, who's in the London Catholic School Board, has been doing some stuff with dash and dot. So I'll just go back to my slide here. This is the dash and dot, and that's a really neat primary coding tool. However, it's a little bit expensive, so it's close to about $170, but it's pretty neat. So you can go to that, or you can check out that article that was written by her if you're interested. And she talks about how is intergenerational learning. So she has been teaching for a number of years, but she just started coding, and she's doing coding with her classes right now, and she's a special education teacher and seeing amazing results. So just a little bit of inspiration on that article, or that magazine. So Math and Code, let's type it in one more time, .com, if you're interested. So that's everything that I have. I tend to talk a little bit faster than what I planned, but there's some time now. I know a lot of you probably have report cards and things like that to do. But if you're interested in staying on to ask a few questions, I'm more than happy to stay on for a bit. Feel free to contact me with any questions. Again, my Twitter handle, Lisa Ann Floyd. Just don't forget the E. Two different people, or email me at lisa@fairchancelearning.com, and I'm more than happy to help you out. Now I will type in the link that I made with some of the resources, and based on requests throughout this session, I will add a couple more links as well, because I just saw some questions, and I do have some other resources to share. So bit.ly/codingshape. I threw on some of the links that I've covered in this session today, and there will also be a few other links that I'll share with you, and there's some screen prints as well. So thank you so much for joining me, and good luck with the coding in your math classes. Hope I've inspired you a little bit. And again, I'll stay on here in case you have some questions.
Yeah, thanks, Lisa. Maybe even people can go back in the chat and try out one of those activities that you did at the beginning and see if they have any questions about that.
So for the Makey, you can contact me if you wish. We do have them at Fair Chance Learning, or you can just go to the Makey website and purchase them from them. They retail of over $65, the Makey. At Fair Chance, we do have a PD, Professional Development for Makey that includes 20 Makey with the PD. The address of the slide show. Okay, so this one here. I think that's it there. How do you get the PD? Oh, just contact me and I can give you the details, Allison. So Lisa at fairchancelearning.com if you're interested and your school board's interested. I'm glad that you're going to try those activities, Sharon. So Sharon. What's awesome is when I share ideas with teachers, it's even cooler when I see people take the ideas and remix them and change them into something even better. And I'd love it if you'd share those ideas with me so that I can share it with other people and we can just kind of keep building capacity where coding is concerned. Encourage your school boards to consider doing some coding, professional development, or maybe purchase some of those items that I mentioned today. I think it's definitely worth it. Awesome. Thank you, Mark. Certainly. In our TLP, we have a lot of people doing coding in French class, even for positional language as well. And I think just to make sure you did get to see the different languages in Scratch, and it's also the Tickle app's available in French as well. I'm just trying to keep up with these questions, so sorry, I'm going to scroll down a bit so I can see. Circle tutorials with students. Oh, awesome to see that you've done some circle tutorials with students. Awesome, thank you, Sharon. Thank you, Sophie. For Scratch, you do not need to sign into Scratch. You can just hit create and start coding. If you want your students to share, or to save their work, you have two options. One, you can have them sign into Scratch. You can set up a teacher account. I believe it takes 24 hours to set up though. So you can set up a teacher account and give your students their own accounts within your teacher account. The other option is to have them just save their Scratch projects onto the hard drive of the computer. So they don't have to sign in order to save their Scratch projects. Yes, thank you, Jamie. It's a great summary. Right, so Allison, I haven't actually tried adding students to my teacher account yet. I've heard that they're a bit of a headache, so you could check with Scratch, like send them an email, sometimes they will respond, and get them to clarify that for you, or I'll try and check it out myself as well. Those are the other questions. Scratch Junior is iPad or tablet only. Yes, it's an app. You can use a Chromebook for Scratch Junior as well. Hopscotch, I'm not sure if it's a Chromebook app, but it is tablet only. So yeah, there's no web version for Scratch Junior and Hopscotch. But the Chromebooks, you can get the app. I've checked out saving on Scratch Junior. When I use the iPads, my old programs are up there. So if they're using the same devices, you should see their Scratch Junior program. But for Scratch Junior, there is a way that they can share it with each other. I've tried it. It's a little bit confusing though, like saving to their Google Drive, for example. So I don't recommend that. What I would have them do is maybe take pictures of their code or take a video of what they've created. But when I do use Scratch Junior, I can always go back in and see my previous programs that I've made. Just depends how many people are using the devices in that particular program. So Scott responded to Joe's question about Hopscotch. Yeah, so I guess it's iOS only. Awesome, I'm glad that you found it useful.
So I just want to finish up the couple things that we need to do from the OTF side. So there's just a couple of announcements, and one of them is the feedback. So if you could there's a couple ways you could get to the feedback link. One of them is when you log out of, when you log